Hello everyone, this is Vijay from Simulation Hub team. Today I am going to talk about the collaboration recently we have done with Onshape. Onshape has launched a app store and Simulation Hub is now available as fully integrated app within Onshape. So this demonstration is about my first experience using Onshape and Simulation Hub. I have used conceptual design of a butterfly valve for demonstration purpose. So the power of CFD simulation in hands of designers whenever and wherever they need it is a part of Simulation Hub's vision. In today's era of product development, the first stage when any idea is concerned is to convert the conceptual idea into its computer representation, or we also refer it as a 3D CAD model. This CAD model is then migrated to downstream domains like rendering, CAM, 3D printing, CFD, FEA, and many more. CFD simulation is only one piece of a puzzle in complete product design cycle. Simulation stage needs CAD model as an input. Along with the simulation tool, designer needs CAD tool to design and optimize the product. So this is what I think when it comes to a designer and his innovation. He has an idea, he has a conceptual idea in his mind. The first thing that he does is convert that conceptual idea into its computer representation or 3D CAD model. Then as far as optimizing the product for flow and thermal performance, that goes to a downstream domain called as CFD or computational fluid dynamics. So using CFD, he visualizes the flow, its performance. And if there are certain problems, then he comes with the better idea. He analyzes how exactly flow looks like, and then he tries to optimize the performance, comes with a better idea. And then again that better idea is converted into its CAD model, then migrated to CFD, analyze the results, comes with a better idea. So this is the whole design and innovation cycle. So to connect all the dots and to give true power of virtual realization of the product to designer, Simulation Hub and Onshape has came together. Onshape is a fully cloud 3D system. It gives designers access to all that is required to convert conceptual idea into a 3D CAD model. Simulation Hub is a cloud-based CFD app which gives power of CFD simulation to the designer. So in order to give a complete power to the designer, we have integrated a Simulation Hub with Onshape so that he can create a CAD model on Onshape and then evaluate the performance of the CAD model or his design using Simulation Hub. So Simulation Hub is now available as an integrated app within Onshape environment. It has a seamless integration with Onshape CAD data. So this seamless integration recognizes and propagates all the design changes. You need not to download the CAD model, upload the CAD model, or whenever you do a change in a CAD design, that change is recognized within Simulation Hub. So this seamless integration allows designers to carry a quick design iterations based on simulation results. So little bit about Onshape and Simulation Hub before we start the demo. Onshape is the only company in the world with 100% focused on a cloud and mobile CAD, offering the first professional 3D CAD system that lets everyone on a design team to work together using any web browser, phone or tablet. So it's a powerful system so that the designer and the team can work together, convert their conceptual ideas into a 3D CAD model. Simulation Hub is easy to use cloud-based CFD app for designers, and it works from mobile, tablets, desktop devices. So at Simulation Hub, we have redefined the traditional simulation process for complex CAD model, even with dirty CAD assemblies. The main focus at Simulation Hub, the core of Simulation Hub is CFD simulation tool for designers. So the workflow is presented in a very simple format so that it is easy for a designer to use that analysis tool. So Simulation Hub is designed in a such a way that it can be accessed as a software as service from mobile tablets and desktop devices. So the philosophy of Onshape and simulationHub makes them a natural partner to partner together and bring the power of CAD and CFD simulation available and accessible to designer. So to demonstrate this integration, I have selected a simple problem. It's a butterfly valve with 200 ID. When this valve is fully opened, the flow rate is about 250 kg per second. And what I want to do is I want to check the performance when the opening position is 30, 45, 60 and 75 degree. So this is a simple model. So what I'm going to do is I'm going to demonstrate how we can create this CAD model on Onshape and then do a CFD simulation using simulationHub. So I have logged into my Onshape account. Before I start creating a document, I'll tell you that I am not excellent user of Onshape. So the model might have taken a bit more time compared to what expert user would take. So I will create a document called butterfly valve design. So first I am going to create a pipe. The OD of pipe is 220 and the length of that pipe is 1 meter. Let me add a flange at one end. I have selected flange OD as 350 and the length is 30 Let me add a similar flange at other end. Now I am going to remove the material of size 200 So now what I got is a basic pipe with flange at two ends. Let me create holes in both the flanges. So this is all not necessary as far as CFD simulation is concerned, but I am just trying to create the model which is more realistic. For CFD, what we need is just the internal domain. But in this case, I am going to create all the solid parts and the fluid volume is automatically extracted by simulationHub. So let me drill some holes in one flange, 6 number of holes to be specific. There might be better ways of doing these operations, but I'm just using the ones which I am aware of. So while using Onshape application, I never got a feel that it's a cloud-based application. I'm using it in web browser. It gives me experience which is as good as what I would get when I use a desktop applications. So I got a pipe with two flanges at the end and the holes in it. Now I'm going to create the disc, the butterfly valve disc. So I have created an offset plane which is 300 inside the pipe. So let me create a disc. So the OD of the disc is same as that of ID of a pipe. Let me extrude this to get the thickness of the disc. So I have extruded that on both the sides. I'll add some fillet. So this is because I have added that material. So let me add it as a new material so that the disc part is created differently. So now I'm going to create the rotation spindle. So the diameter of the spindle is 50 and which is at the center of the disc, so 300 inside the pipe flange. So these are actually not the correct dimensions or actual dimensions. I'm just trying to create a good visual representation of the disc and the spindle. So you might see I'm doing some mistakes in creating the model. Let me add the similar part at the top. As I said before, this is not necessary for CFD, but I'm just trying to create a good visual representation of the butterfly valve. And this is also to demo that no matter what complex geometry you have, simulationHub handles it excellently. So let me add a structure at the top which would act as a guide for rotation handle. I have selected all these dimensions on the go, so they might not be perfect, but definitely gives a very good visual representation of valve assembly. So about 70% of my time has gone into creating good visual presentation of the butterfly valve. If I would have done only fluid volume or the geometry necessary for CFD simulation, this might have taken 5 minutes or so. So you can also see how quickly you can create almost a realistic representation of your concept. So the basic model of valve disc and its assembly is created. Now I'm going to add a rotation spindle. As I said, I am using the tools and techniques which I am aware of within the Onshape. There might be another better ways of creating this geometry, but knowing the capabilities of Onshape is not the purpose of this demo. So a better user than me might create this model very quickly. So let me add a arm to a rotation spindle. All these dimensions are relative just to create a better visual representation. Let's add some fillets to make it more realistic. So I'm trying to add a grip to the handle. Again, add some fillets to make it look more realistic or beautiful, I would say. Okay, so looks like the model is ready. Now what we need to do is we need to add a rotation axis so that I can rotate this valve assembly or the disc assembly with certain angle. So I'm going to use this vertical line which is exactly at the center of the spindle as a rotation axis. So the model is ready. Let me rename this as a rotation axis. Now what I'm going to do next is merge certain components. So the pipe end flanges and two end caps of the valve assembly, I'm going to merge them together in one part called as a pipe, and the remaining assembly I'm going to merge it, or remaining parts I'm going to merge it into a part name called as butterfly valve. So unite all these parts. So rename this as a pipe. And then this is the valve or disc assembly. Fine, so the model is ready now as far as the construction is concerned for CFD simulations. So whenever I want to rotate the valve assembly, I'll use rotate operation on the part called as valve. I'll use axis of rotation, and now you can see that you can easily rotate this valve disc. So this is all about creating the model quickly on Onshape. Now we will see how we can do a simulation of this butterfly valve using simulationHub. So the first simulation we are going to do is with 30-degree opening angle. So let me rotate this butterfly valve with 30-degree. So you can see that simulationHub being an integrated app, you will see simulationHub in Add Application tab available within Onshape. So for using simulationHub, you need not to leave the environment of Onshape. It is available within the Onshape environment. So I will add simulationHub. Now at the bottom you can notice that the simulationHub tab is added. I'll select the document on which I would want to do a simulation. I'll give a name to the simulation. In this case it is 30-degree opening angle, so I am using butterfly valve design 30-degree as a name to my simulation, and I'll click on create simulation. So what it does is it takes the model available on Onshape and uploads it to the simulationHub. And opens a 3D viewer of a simulationHub. You can see that the geometry is transferred as it is with 30-degree opening angle with all the features that you have created on Onshape. Now the first part of simulation on simulationHub is extracting the fluid domain. So for extraction of a fluid domain, what you need is select 2 points, the center of which lies within the fluid domain. So I'm going to select 2 points. Now you can see the center point is marked in a red color, and I'm very sure that it is within the fluid domain. So once you submit the job, what it does is it takes this geometry, goes to the simulationHub server, and extracts the fluid domain using fluid volume extraction tool written by simulationHub. Now just pulling down the information about the fluid domain. You can see in the fluid domain that the end caps are automatically added by our algorithm. There is no need that the fluid domain is watertight. simulationHub fluid volume extraction algorithm automatically identifies it and puts the end cap. You can see that all the solid parts are considered while extracting the fluid domain. The next stage is to provide the boundary conditions. So I'm going to select one face, which is inlet, and I'm going to use mass flow rate as the boundary condition for it. So for 30-degree opening angle, the mass flow rate is 75 kg per second. And the outlet is exposed to atmospheric pressure. So the boundary conditions are provided. We can always see the definition. If you see inlet is 75 kg per second, all remaining walls are treated as walls, which is no slip boundary condition, and outlet is static pressure at outlet, zero static pressure at outlet. So the setup is ready in terms of boundary conditions. Now let's submit this. The working fluid is water. And for now I am going to select coarse mesh as a setting. So with these settings, it takes all the information, goes on simulationHub server and starts CFD calculations. You can see the progress of the simulation. So the simulation is completed. Now it is downloading the CFD results. Time taken for downloading the CFD results depends on the complexity and the data. So the default view is the path lines or flow lines. You can see that the flow is accelerating as it goes near to the disk or small openings around the disk. You can also see path lines with vectors. You can also see the results on cut sections. So currently there are two variables available. One is the pressure and other is velocity on the cut section in all three directions. So this is the Z cut section showing the pressure. And this is the velocity results on that cut section. You can see that the maximum velocity is 35.79 meter per second, which is in the very small opening between butterfly valve disc and the pipe. You can also see some quantitative values like what is the pressure at the inlet, static as well as total pressure, and what is the flow rate at inlet and outlet. So the simulation at 30-degree opening angle is done. So let's do a simulation at another opening angle which is 45-degree. So I'll go to Onshape and change the opening angle to 45-degree. Now the moment you do any changes in the geometry, simulationHub recognize it. Now you will see another icon called as geometry change detected. If you click on that icon and if the results are available, it will show that do you want to edit that stage or do you want to update this geometry. In normal design cycle you might say yes, but in this case I would like to do different simulations at different opening angle. So let me add another simulationHub application and create a new simulation with 45-degree opening. So what I would have at the end of the simulation is different simulations associated with the geometry at different opening angle. So it is creating a project on simulation hub, taking that modified geometry which is 45-degree opening angle. You can see that the opening angle is 45-degree now, and that geometry is uploaded to simulation hub. The procedure after this is same. Extract the fluid volume by providing 2 points. Once the fluid volume is extracted, you need to set the boundary conditions and run the simulation. So the procedure is going to remain same, divided into simple 5 steps. So it is extracting a fluid volume for this opening angle. And now let's provide the boundary conditions on this fluid volume. For this opening angle, the mass flow rate is 100 kg per second. Outlet is atmospheric pressure. And let's submit this simulation for CFD calculations. Now once you submit the simulation on simulation hub, you need not to wait. You can always modify the geometry and submit another run. So now the next run is for 60-degree opening angle. Add the application, create the project. Provide 2 points for extracting a fluid domain. So for this opening angle, the mass flow rate is 150 kg per second. Outlet is same, atmospheric pressure. And submit the run as water as a fluid and coarse mesh setup. So let's rotate it for our last opening angle, which is 75 degree. Add simulation hub application, provide name of the project, and create the simulation. Provide 2 points for extracting fluid volume. Once the fluid volume is extracted, provide inlet and outlet conditions. So in this case, it is 185 kg per second, and outlet is atmospheric pressure. So all the simulations are now submitted for simulation. Once the job is submitted on Simulation Hub, you will get the notification. Once the job is also completed, you will get an email notification saying that your job is completed. So let's go and see what happened to our 60 degree opening angle. So looks like the simulation is still running. This is the simulation at 75 degree opening angle. Okay, the simulation at 60 degree is completed now, and it is loading the results. These are the flow lines for 60 degree opening angle. The way we have seen the results for 30 degree, you can also see the results for 60 degree. These are the flow lines with vectors. And these are few of the cut sections and the pressure and velocity distribution on those cut sections. Now if you see, the max velocity is reduced, it's 12.56 in this case compared to the velocity in case of 30 degree opening angle. That is mainly because the bigger opening available between the disc and the pipe. This is the status of simulation at 75 degree. It's completed and now loading the results. These are the path lines. As the opening is a bit wider, you can see the max velocity is gone down. It is 10.55 meter per second. And these are the results at few of the cut sections. and these are the quantitative values, the pressure, total and static pressure at inlet, as well as mass flow rate. Okay, so all the 4 simulations are done now. So let's open them at a time and see what is the difference between the results for those 4 simulations. So I'll go to Onshape document, add an application, simulationHub, and this time I'm not going to create the new project or new simulation. I'm going to open the previous simulations. So I'll select the document, I'll go to open simulation, select the document, and you will see that there are 4 simulations which we have done and listed here. So I'll open 30° first. I'll rename this tab as simulationHub 30°. Now I'll add simulationHub application again. Click on open simulation. Select the document. It will list all the simulations available. Select the 45° and open simulation. Rename the tab with 45° label. And do the same for remaining 2 simulations. This is 60° simulation. And let's open the final one, which is 75°. So we got all 4 simulations open now. So let's see results one by one. So first is to check the quantitative values, which are pressure drops. So I can go and select all the quantitative values for each simulation and compare them to each other. So these are the static and total pressure values at inlet and outlet. Now you will see that the pressure drop is increasing as the angle of rotation is less. So that is mainly because of the flow separation behind the valve. Now these are the cut section views This one is for 30°. So these are the results, pressure values on the sections. You can see that the maximum velocity is 35.79 in case of 30°. Now it has gone down, and for 75° the velocity is 10.55 meter per second. So this is the way you can quickly do different design iterations, different simulations using Onshape and simulationHub as an integrated app within Onshape. Thanks for watching this demonstration. We will include more and more examples wherein Onshape is used to create a CAD model and simulationHub is used to do a simulation.